Good evening. I'm Jennifer Rabb and have the great privilege of serving as the president of Hunter College, where the American dream continues to come true. I'm delighted to join another event with the Child Mind Institute, continuing a partnership that has lasted more than 10 years. At Hunter College, we are working to produce the next generation of social workers, teachers, psychologists, nurses, and public health professionals who we hope will join the movement that the Child Mind Institute is leading. The On the Shoulders of Giants Symposium celebrates the spirit of scientific collaboration, bringing together world-class researchers, children's mental health care experts, educators, parents, and young people. This spirit of collaboration, curiosity, and academic excellence is so aligned with our values at Hunter, and we are honored to join the Child Mind Institute in celebrating the scientific leaders of the future. Hunter College is deeply committed to increasing opportunity for young New Yorkers with exceptional ability in the sciences, particularly those who are focusing on the critical fields that help us lead to improvements in mental health. Partnerships with organizations like the Child Mind Institute, we believe, help us towards fulfilling our historic commitment to the Hunter College motto, Mihi Curia Futori, the care of the future is mine. That's why I am particularly proud to recognize the winners of the Rising Scientists Awards. This scholarship is awarded annually to 5 high school students who show exceptional promise in the fields of child and adolescent mental health or pediatric neuroscience. Over the past decade, these awards have become recognized as the true sign of distinction. Past awardees have already gone on to work in prestigious laboratories, university and public organizations such as Weill Cornell, Memorial Sloan Kettering, Mount Sinai, Stony Brook, and Doctors Without Borders. So we are expecting great things from today's outstanding young people and award winners. We congratulate these winners and look forward to celebrating your achievements today and in the future. And I hope some of the winners will consider Hunter College for their higher education experience. We would be honored to have any of you in our student body and would love to support your future. And now I am deeply honored to introduce my dear friend, Dr. Harold Koplowitz, president of the Child Mind Institute, a phenomenal colleague and one of the extraordinary leaders in public mental health in this country. It's actually good for one's mental health to have friends like Harold, someone who's looking to better our lives and the lives of everyone's children. Harold is just an extraordinary leader, and I am so happy to be his partner at Hunter College. We thank Dr. Koplowitz and the wonderful team at CMI for their commitment to Hunter College's K-12 system. We rely on them in good times and in crises to help support the mental health of the youngest members of the Hunter College family. They have gone above and beyond in their support of Hunter College as they have for the city of New York. Thank you, Harold, and to CMI for all you do for this city, state, and nation. You are an extraordinary leader. It is a pleasure to welcome Dr. Harold Koplowitz.
Good afternoon and welcome to our 11th annual Rising Scientist Award ceremony. Thank you all, parents, family members, teachers, nominators, and most of all, the rising scientists for joining us this afternoon. And thank you to my friend, Jennifer Rabb, president of Hunter College, for such a wonderful introduction, and to Hunter College for their years of partnership and support of the Rising Scientist program. Hunter College is a vital incubator, as Jennifer has just told us, for the next generation of scientists, social workers, teachers, psychologists, and public health professionals who are making an impact in the children's mental health crisis that we are facing now in this country and around the world. It's the mission of the Child Mind Institute to transform mental health care for children everywhere. We're the leading independent nonprofit in children's mental health, operating 3 mission areas that work together for greater impact: care, education, and science. Our clinicians provide gold standard, evidence-based treatment to thousands of kids annually through our clinical centers and in-school programs. And we deliver free resources to millions of families and training to hundreds of educators each year, so more kids get the help they need. And our researchers and engineers are uncovering the causes of mental health and learning disorders to develop tomorrow's breakthrough treatments. The science program at the Chalmers Institute is a global leader in open source innovation and data sharing in neuroscience, brain imaging, and wearable behavioral health technologies, and internet-based treatment and assessment. So our tools for discovery are being used around the world, and the work of our engineers and data scientists is changing how researchers do science everywhere. Our Healthy Brain Network study is enrolling 7,500 young people with mental health and learning disorders to uncover the biomarkers of these disorders. Our Autism Center is studying changes in the developing brain in young children with autism, and our newest initiatives are testing clinical interventions and real-world tracking of children's mood, sleep, and activity. And through all of our research projects, families receive comprehensive evaluations, recommendations, and treatment referrals. But most of all, we know that we need to create a culture of collaboration in neuroscience and encourage the next generation of scientists if we are going to make an impact on such a complex issue as children's mental health. And that's why we started the Rising Scientist Scholarship. Our rising scientists may be the next generation, but they can still probably benefit from a giant of our own generation. Please help me welcome a mentor who's presenting at the On the Shoulders of Giants Symposium today, the recipient of our 2022 Sarah Gunn Prize for Research and Mentorship, Dr. Margaret McCarthy. Dr. McCarthy, will you share a few words of wisdom?
Good afternoon, and thank you for the opportunity. And I'd like to offer my congratulations to our rising scientists as well. Having read all your bios, I am sure that this recognition for your accomplishments is only the first of many to come. So I've been asked to give some advice that I give as a mentor to my own students over the last 30 years of running my own research laboratory, and I have 5 sort of highlights that I would like to offer to each of you. The first is passion, and I think that it's obvious that all of you have passion. You've already demonstrated that early on in your careers, but it's important to understand, where is your passion coming from? Is it coming from within, or is it being externally executed upon you from your parents, your peers, from social media, from who knows whatever source, other than something inside? If science is something that fills you with joy and awe and curiosity, that's a passion, and you want to protect that with all your might throughout your career, because there are going to be many, many challenges against that passion. One of those is going to be the second item, unrelenting criticism. I like to say that science is really a rough and tumble sport. The criticism never stops. You're always going to be told that something about your idea is wrong. Your data itself is going to laugh in your face and fail you. Your grants are not going to be funded. Your papers aren't going to be published. Your drug trials are going to fail. This is a relentless and integral part of the life of a scientist. And the most important thing to remember is that it's about the science. It's not about you as a person. So when you receive those harsh criticisms, remember that they are about science, and they are there to help you be a better scientist. So when you get knocked onto the mat, get back up again and say, what did I just learn? How was it that I got tackled there? What can I do better in the next time around to avoid making that mistake? And you'll be a better scientist. Don't turn on yourself and say that you're a failure and you're a bad scientist. There's no such thing. It was just perhaps not the best experiment you could have designed. The third piece of advice is nonlinearity. We all try to think, I'm going to do task number 1, task number 2, task number 3. This will not serve you well as a scientist, both in terms of thinking creatively about solving scientific problems. Sometimes things are very nonlinear. They're very much in a network or in a curved relationship that you didn't anticipate. So you want to be open to other ideas, right? Don't marry your hypothesis, as we always say. You can date it. You can even maybe live with it for a little while, but don't marry it. Make sure that you keep in mind other interesting ideas and ways to interpret your own data. But also don't be linear when it comes to roadblocks. There's going to be barriers. There's just going to be all sorts of technical and mechanistic barriers to achieving what you want. And instead of just bashing against that roadblock, go around it, go under it, go over it, or just take another road. And that brings me to advice number 4, which is, if you do need to take another road or you need a way around that roadblock, ask for help. Nobody can be an expert at everything these days. In the field of neuroscience, the reason it is so incredibly exciting is that it is one of the most complex and rapidly growing fields in all of biomedicine. And you cannot be an expert at everything. So you need to seek the help of other individuals, and you never want to be afraid to say, I don't have the answers. There's no such thing as a dumb question. Right? So seek out your colleagues, just go to the internet, just Google, just cold email people. You'd be amazed at the responses that you'll get. Which brings me to my very last piece of advice, which is what I call the no BS rule. As I said, you're never gonna know everything. So if there's something you don't know, say so, admit it to yourself. That's the first most important person to tell yourself that you don't know something, but never try to pretend in the face of another scientist that you know something that you don't, right? Unless you're absolutely sure. So protect your intellectual reputation. There is no shame in not knowing the answer, because we can't possibly all know everything in this amazing field of neuroscience in which we're trying to solve the biggest problem there is, which is to understand how the brain works. So those are my 5 pieces of advice. Follow those, and I'm sure you're going to have a long and successful career. And again, my congratulations to each of you.
Margaret, thank you very much. Before I announce the winners, I want to recognize the support network that has helped you all succeed so remarkably. The teachers and mentors who recognize and celebrate your talent, the school administrators who maintain the environment necessary for you all to thrive, and most importantly, the families and parents who have nurtured your curiosity, confidence, and discipline that goes into the making of a great scientist. Many of them have joined us today to watch you receive this award and share in this celebration. This past school year presented many challenges for students. Despite this, we received extraordinary nominees from across the country whose persuasive applications were carefully evaluated by our Child Mind Institute judges, whom I'd like to acknowledge. Thank you to Dr. Paul Matrani, Clinical Director, and our team of research scientists, Drs. Alex Franco, Ting Wao, and Aki Nicolaitis, and Greg Kiar. My warmest congratulations to all of the winners of the 2022 Rising Scientist Award, which carries a $2,000 scholarship. The first award is presented to Hannah Cho of North Hollywood High School in Los Angeles, California. Hannah's research interests are in neuroscience and biomedical engineering. Her current work looks at the effect of meditation on teachers struggling during the COVID-19 pandemic. Her work was recognized by both the LA County Science Fair and the Journal of Young Explorers Meta Competition. She was featured at the Global Health Learners Conference at the Johns Hopkins University. Hannah leads her school's Science Research Club and American Computer Science Leaders Club, and she founded the Women in Tech Club. In her free time, Hannah volunteers as a crisis counselor for the California Youth Crisis Line, enjoys writing poetry, and acts as editor-in-chief of her school's literature publication. Hannah, will you now join us for a brief presentation of your research?
Thank you for the introduction. Hi, everyone. Thanks for coming. My name is Hannah, and my presentation is called Meditation's Physiological Effects on the Well-Beings of Teachers Undergoing Stress. First of all, stress is one of the 5 leading causes of death, and over the pandemic, it has only gone worse as a 30% increase of teachers undergoing stress has been reported. On top of that, 75% of teachers report stress, showing that they're exceptionally susceptible to stress. Meditation has long been known as a treatment for stress, and the 2 types I decide to focus on in my research are visual focus and visual and focus meditation. Visual being imagining something, and focus being counting beads on a string or counting breaths and activities like that. The autonomic nervous system is one section of our central nervous system responsible for our involuntary actions. Behind the autonomic nervous system, there are 2 sections called the sympathetic nervous system and the parasympathetic nervous system. Sympathetic is well known for its stress reactions or fight or flight, such as increasing heart rate, and parasympathetic is known for its peace or rest or digest reactions, such as decreasing heartbeat. I measured these reactions using heart rate variability, which is the variability of time in between each heartbeat. So lower heart rate variability, for example, would mean that there's less time in between each heartbeat, meaning more stress activation or SNS index. And these indicators were averaged out to create PNS or SNS index values, which are measures of standard deviations. For example, shown here, a PNS index of 1.94 means that this person is 1.94 standard deviations above the average population, meaning in this case, they are more calm. So how I went about collecting my data is that I had teacher participants wear wristbands from January to May of 2021, where they join a Zoom meeting led by a licensed therapist. This therapist will conduct either visual meditation or focused meditation each month. Then they would focus in a discussion where they talk about the stress in their lives and how the meditation felt. The data was then exported to an analysis platform where I selected 2 samples for meditation engagement each. Then they were all corrected for errors and data. For my results, I found that in visualization meditation months, which were January and April, there were mixed results, as in January, most participants had lower calm and higher stress levels during meditation, which was not usual. In April, most participants did have higher calm levels, but they also had mixed stress levels. But in the focused meditation months, there was an even result, as there was low stress level and higher calm level during meditation. The second set of results showed that there was a smaller heart rate during meditation and a higher heart rate during engagement, showing an increase in heart rate for 6 out of 8 participants. There was also an inverse relationship exhibited with RR decreasing. Second, there's an SD2 decrease for 5 out of 8 participants, shown here. The point care plot SD2 indicator was higher during meditation for 5 out of 8 participants. In total, 64% of the data sets had a higher PNS index or higher calm level during meditation than during engagement, and this aligns with an earlier study conducted in 2018. For my conclusion, I found a number of findings, first of all being that the SNS indexes were positive and that the PNS indexes were negative. This could be due to a variety of factors, one being that teachers are more stressed than the average population, which I discussed in my introduction. It could also be due to the idea that the teachers were in a social setting and not completely at rest. And third, most of the participants were female, who are statistically proven to have more stress than males, so that could have played a part in these results. Second, the percent of changes of indexes were different for every participant, which implies that meditation does impact everyone in different magnitudes. For visualization meditation, it can be assumed that these mixed results could be due to a variety of covariates, including relatability, comfort, personality such as extrovertedness or introvertedness, age, and gender. In January, there could have been more stress than April due to the emotion level or engagement required by the task. As in January, participants had to be trees, and in April, participants would do body scan meditation, which they could have resonated with more easily. In focused meditation, there is an even trend where meditation reduced stress and promoted recovery, proving that focused meditation could be a very effective and valid way for treatment. And in May, there is a larger percent change in PNS, indicating that focused meditation can change PNS more strongly. As for my indicators, a lower heart rate during meditation shows that meditation was less strenuous than engagement, and a decrease in RR supports an inverse relationship between the two that can be dissected later in future research. A higher SD2 during meditation also indicates a long-term heart rate variability. This means that meditation does in fact have long-term heart health benefits. In the future, I would like to focus my research on having baseline measurements so I can conduct using a middle ground to go off of. I'd also like to cross-analyze other factors that the ANS is responsible for, such as sweat, blood pressure, and eye movement, to get a bigger picture of how the body is affected by stress. And then I'd also like to see covariates such as the gender, age, comfort, emotion, and personality that could have been the reason for the visualization meditation's varied results. These are my references, and I'd like to acknowledge the USC Brain and Creativity Institute for its help and data. I'd like to also acknowledge my teacher, Mr. Main, for his support, and my family for helping me. Thank you to the audience, and if you have any questions, please feel free to contact this email address. Thank you so much for coming.
Thank you, Hannah, for sharing your work, and congratulations on receiving this award. The next award goes to Noemie Durand of BASIS DC in Washington, DC. Noemie is a research assistant intern at Child Trends in the Department of Behavioral Health, where they analyze survey data on coping skills and student health and research best practices for school mental health supports. They also work at the Young Women's Project, where they have created a virtual wellness center and advocate for better mental health supports in schools. In 2021, Noemie started a nonprofit called Karna, focused on increasing teen access to mental health and wellness resources. They have worked with American University students to evaluate and make suggestions for the Latin American Youth Center's teen health program. They've written research articles for Each Mind, a teen-led mental health magazine. Outside of research, Noemie leads both their school's policy debate team and National Honor Society, and is a member of their school's varsity basketball and track teams. Noemie, will you now join us for a brief presentation of their research?
My name is Noemie Durand, and I'm so excited to share my work with you guys today. So first things first, I'm a 12th grader at Basis DC, which is a charter school in downtown DC. I was born in Switzerland, but I've lived in the US since I was 6. And I was first interested in psychology because I saw the impacts that mental health had on myself and my friends, especially during COVID. And so I'm interested in pursuing clinical and research psychology through my continuing education. Today, I'll be presenting about 6 aspects of my work in mental health and research. So the beginning. So first of all, I participated in a program called Research for Change. This was a partnership with American University, and it was meant to teach me about the research process. And so we evaluated the Latin American Youth Center's health program. And so we sent out surveys to everyone who had participated in the program, and we used that data to create suggestions for the program to move forward. This is what initiated my passion for research as a means of exploring impacts of health programs in communities, which is a theme that pops up through many aspects of my work. Earlier that year, I had started working with the Young Women's Project, which is a nonprofit in DC, and my first year with them was about sexual health. So I would learn about it during the week, and then I would also disseminate that information back to my peers, especially through Instagram and other social media, since that was our virtual learning year. My second year with the Young Women's Project was about mental health. And so we worked on a student online support virtual wellness center, which was a compilation of almost 200 resources for students relating to mental health. And then the third year, which is this year, is again mental health, and this time we'll be focusing on mental health supports in schools. Then after that, or during that year, I was also working with Each Mind, which is a teen-led nonprofit organization, and they are a magazine. So I was writing and editing research articles for them. And so some examples of articles that I wrote for them was misconceptions about bisexuality, how mental health affects intimacy and sex and vice versa, and the differences between generations in terms of stigma and attitudes towards mental health. And as you can see, many of those themes relate back to sexual health and mental health, which are passions that I developed through my work at the Young Women's Project. Then early last year, I started a nonprofit called Karna. So we are a nonprofit. Sorry about that. We are a nonprofit by teens for teens about mental health and wellness. So the idea is that as teens, we have a unique perspective on other teens' mental health because we're going through the same thing. And so we're able to provide relevant and digestible resources surrounding topics such as coping with stress, growing confidence, or meditation. All these information packets, as we call them, are based on evidence and reputable sources and are sprinkled with some personal experience as well. We also provide self-care products in the form of gift boxes to yourself or a loved one in an attempt to start the conversation around mental wellness and decrease stigma. And throughout this past year, we've been able to grow into a team of 14 students and 16 info packets and tons of new projects such as fundraisers and a podcast, and we're excited to keep growing. Earlier this fall, I also started working as an intern with Child Trends. Child Trends is a child psychology research organization, and so I'm essentially acting as a research assistant there. Right now, I'm currently working on a project with the Department of Behavioral Health to analyze Child Trends survey data from last year to determine the impact of their work on school behavioral health. And we're also working on some best practices for school behavioral health and research on coping skills for students. And so that's a great opportunity, and I'm able to work with some great mental health professionals there. And then also throughout all of my work, I've been learning about mental health issues and possible solutions within my community, particularly my school. And so this puts me in a great position to provide a student perspective to people who are working within the government. So I've done a lot of things relating to policy. I've provided several testimonies to council about mental and sexual health. I've participated in youth adult partnership meetings with the Department of Behavioral Health to give, again, a student perspective on these issues. And then just yesterday, I was put into the Healthy Youth in Schools Commission for the mayor's office, where again, I'll be able to provide a student perspective on all of this and make suggestions on how we can improve mental health in schools. And that's it. Thank you so much.
Thank you, Noemie, for sharing your work, and congratulations on receiving this award. For our next award, please join us in congratulating Ty Gelman of John F. Kennedy High School in Bellmore, New York. Ty's current research focuses on using a fruit fly model to assess the effects of dietary restriction and exercise on spinal muscular atrophy, a neuromuscular degenerative disorder. He previously completed a data analysis project on the identification of biomarkers in canines with post-traumatic osteoarthritis. Ty is an avid coder, completing independent projects and attaining internships with large companies such as United Pet Care. He's a member of the Advanced Science Research Program at his high school, and when he's not conducting research or engaged in academics, Ty stays busy with his school's robotics club, hackathon team, and varsity soccer team. Ty, will you now join us for a brief presentation of your research?
Hello, everyone. Before beginning my presentation, I would like to thank the Child Mind Institute for awarding me with this scholarship and for providing me with the opportunity to present my research to you all today. I appreciate it tremendously. So my name is Ty Gelman, and today I'll be presenting my research on the concurrent effects of dietary restriction and exercise on a Drosophila melanogaster model of spinal muscular atrophy. So you may be wondering, what is spinal muscular atrophy? Well, SMA is a neuromuscular degenerative disorder which results from mutations in the survival motor neurons 1 gene, which leads to a decreased amount of the SMN protein produced. As a result of a deficiency in the SMN protein, both motor neurons and muscle tissue are impaired in their functions. SMA is characterized by a decrease in muscle activity, motor function, and a decrease in metabolic rate. Now, Drosophila melanogaster, also known as the common fruit fly, has been used in many other neurodegenerative studies on diseases such as Parkinson's and Alzheimer's. Because of their fully sequenced disease-causing genome, which is nearly 60% homologous to the genome of humans, Drosophila are the perfect model organism for studying SMA. Additionally, previous studies on neurodegenerative diseases have supported the notion that exercise and dietary restriction individually improve symptoms. So this led me to hypothesize that when dietary restriction and exercise were introduced individually, SMA symptoms would improve. However, when introduced simultaneously, strenuous exercise and dietary restriction would worsen the symptoms. Overall, my study included 18 experimental groups. Represented by MSMA, I expressed SMA in muscle tissue. Represented by MNSMA, I expressed SMA in motor neuron tissue. And I had a control group of wild-type flies as well. I induced 3 levels of exercise intensity: no exercise, moderate exercise, and strenuous exercise. The intensities differed in their time under activity and time left for recovery prior to testing. Regarding diets, I either gave the flies a protein-deficient diet or a normal diet consisting of favorable proportions of macronutrients. The first assay I used to test the effect of exercise included the construction of a 3D Drosophila rotation device, which I built and programmed myself. This device takes advantage of the fly's innate nature to move in the direction opposing gravity. By constantly flipping the flies upside down in this device, they were constantly forced to move upwards, thus inducing exercise. Moderate exercise groups respond for 15 minutes before testing, and strenuous exercise groups respond for 2 intervals of 15 minutes prior to testing. Now, to actually test the flies, I use an assay known as the negative geotaxis assay. I put the flies in vials and tapped it 3 times on a table to knock the flies to the bottom of the vial. I then timed the time it took for the median fly to cross the middle of the vial, which was used as an indicator for fly health, and more specifically, their motor function abilities. Next, to test the effect of exercise and metabolic rate, I created individual respirometers and placed them in a vacuum-sealed respirometry chamber. After exercise, I placed 4 flies in each respirometer, waited 1 hour, and measured the displacement of the dyed water in each respirometer, allowing for the determination of relative metabolic rates. Now, these assays were carried out on flies in both dietary groups and amongst the 3 genotypes of flies. After experimentation, to test the significance of my data, I carried out multiple non-parametric linear regressions and multivariate t-tests. I observed that significant differences in slopes were found between no exercise normal diet groups and strenuous exercise dietary restriction groups. In this first chart, there's a clear visible distinction between geotaxis times for the strenuous exercise dietary restricted regimen group as compared to the other regimen groups. In the second chart, the strenuous exercise dietary restricted flies produce less CO2 than the other regimens as well. This suggests that the strenuous exercise dietary restriction regimen bear the worst symptoms on SMA flies, decreasing motor function, and decreasing metabolic rate more than any other regimen. So due to a lack of resources, I had to custom build my own carbon dioxide respirometry chamber, as opposed to purchasing a costly but likely more accurate chamber. Additionally, flies in the dietary restricted group likely consumed varying amounts of food, which may have bared a greater impact on some flies more than others. Now, future research could be to test the effects of other popular diets in wild type and mutant flies, in addition to carrying out other interventions which test other symptoms of SMA, such as longevity. In conclusion, while the dietary restrictive moderate exercise regimen slowed the progression of SMA symptoms, the dietary restrictive strenuous exercise regimen significantly exacerbated the symptoms of SMA. So these findings ultimately hold implications that if a proper diet is not sustained, then the positive effects of exercise can be counterproductive and vice versa. This concludes my presentation, and I'd like to thank you all again for joining me today.
Thank you, Ty, for sharing your work, and congratulations on receiving this award. Our next winner is Lina Iyer of Novi High School in Novi, Michigan. Lina's research interests lie at the intersection of mental health, epigenetics, and computer science. In 2020, Lina helped develop and implement a self-care program for high school students and staff, and to evaluate its impact on mental health with findings published in a peer-reviewed journal. Lina has co-founded 2 nonprofits aimed at addressing mental health and wellness. An app she developed is now collecting preliminary data for a 2023 NIH grant submission. And she placed first regionally at the Health Occupations Students of American Health Education event in 2021, and she received their AP Scholar Award in both 2020 and 2021. Outside of academics, Lina is an award-winning pianist, leads her school's student mental health committee, and is a member of her high school swim team. Lina, will you now join us for a brief presentation of your research?
Thank you for that introduction. Hello, everyone. My name is Lina, and I'm a senior in Novi, Michigan. Just a little bit about myself. I'm interested in researching and solving problems related to mental health and medicine using epigenetics and computer science. I have 2 sisters and a dog named Luke Skywalker. And yes, as you can tell, my family's really into Star Wars. In 2020, during the height of the pandemic, I had the opportunity to work alongside high schoolers across the country in developing a 4-week self-care program, which included tools and activities for mental wellness. This program was divided into 4 areas, each having a week of activities centering on that specific idea and a webinar to start it off. It started with stress to de-stress, then fostering positivity in your daily life, then moved on to explore circadian rhythm and the importance of your sleep cycle, and finished off with the week centered on goal setting and reflection. After creating this program, along with some others at my school, we launched an IRB-approved study to measure the effects of this program on loneliness. We had a total of 108 students participate in this virtual program. At the end of the study, we found a significant decrease in the loneliness levels of the students. We measured loneliness for the control group as well and saw no significant changes. Earlier this year, we were able to conduct another IRB-approved study to extend our previous study and explore the impact of the self-care program for students and staff on anxiety, satisfaction with life, and loneliness using credible and validated scales. We had a total of 179 students and staff who participated in this program across 3 schools. The Heartfulness group is a group that participated in the program from weeks 0 to 4, and the control group participated in this program from weeks 4 to 8. In students, we were able to find a significant decrease in levels of anxiety and loneliness, as well as an increase in satisfaction with life scores in the Heartfulness groups from week 0 to 4, which was maintained from weeks 4 to 8. In the control group, there were no significant changes from week 0 to 4, but a significant decrease in the levels of anxiety and loneliness, and increase in satisfaction with life scores from weeks 4 to 8. In staff, we were also able to find a significant decrease in levels of anxiety and loneliness, as well as an increase in satisfaction with life scores in the Heartfulness group from week 0 to 4, which was maintained from weeks 4 to 8. In the control group, there were no significant changes from weeks 0 to 4, but a significant decrease in the levels of anxiety and loneliness, and increase in satisfaction with life scores from weeks 4 to 8. In the future, I'm working on other research projects utilizing non-invasive methods to explore its impact on chronic diseases such as type 2 diabetes, cyclic vomiting syndrome, and breathing as a tool and coping mechanism. I'd like to thank Child Mind Institute for giving me this award and this chance to present, as well as Heartfulness Institute, Dr. J. Dimapuram, research lead from Heartfulness Institute, my principal, Ms. Nicole Carter, and my parents for all of their support. Thank you.
Thank you, Lina, for sharing your work, and congratulations on receiving this award. And for the final award, please congratulate Amith Vasantha of Basis Independent Silicon Valley in San Jose, California. Amith is passionate about neuroscience. His current research focuses on bradykinesis in Parkinson's disease. Amith has analyzed functional MRI to determine brain regions that could indicate signs of autism spectrum disorder, as well as researched a connection between lucid dreaming and diminishing addictive behaviors. He has completed several Stanford clinical research internships. Amith has presented at student research conferences and has authored publications in science journals. In his free time, Amith enjoys reading, listening to music, traveling, and watching movies. Amith, will you now join us for a brief presentation of your research?
Thank you, and thank you for this opportunity. I'm incredibly excited and honored to present my research on functional connectivity in autism spectrum disorder today. So, well, what is autism spectrum disorder? According to Hull et al., it is a range of developmental disorders characterized by deficits in social communication interaction and restricted and repetitive behaviors. Now, there's incredible difficulty with diagnosing ASD. It's incredibly heterogeneous, which means it includes a wide variety of behavioral and psychiatric features. Additionally, we still can't really nail down the neuropsychological and neurobiological causes of ASD. Now, a key aspect of my research was resting state functional MRI, which analyzes brain signals when the brain isn't presented with any stimuli. And the resting state functional MRI used to analyze connectivity between regions of the brain by measuring correlations in the blood oxygen level dependent signals. Now, functional connectivity in ASD has been researched, but where there's a gap in our knowledge is functional connectivity in the default mode network. The default mode network is a network of the brain that's active during wakeful rest, when the brain isn't presented with any stimuli. As you can see in figure 1 here, it includes the medial prefrontal cortex, the left and right angular gyrus, and the posterior cingulate cortex and precuneus. Now, there has been little research on connectivity in the default mode network, and what little research there is has varying methodology. Now, the default mode network is the focus of my presentation because default mode network controls emotional processing and social interaction. It's also integrated with the limbic system, which is related to the reward pathway. And now these can relate to the social and emotional effects of ASD. The goal of my research was to discover neurocognitive phenotypes of ASD in the default mode network. And I tried to do that by analyzing functional connectivity. My first task was to obtain fMRI data, and I extracted the fMRI data from ABIDE, or the Autism Brain Imaging Data Exchange, which is an open research database including fMRI scan data and assessment score data, as well as other phenotypic data such as age, handedness, medications, and their specific diagnosis. Now, I obtained 672 individual resting state fMRI brain scans of males and females under 21, as well as phenotypic data for each individual. This data was also conformed to a specific brain atlas called a telluric atlas, which I used to select specific regions of interest that I was interested in, namely the regions of the default mode network. You can see the table on the left that shows the specific telluric codes for each of the regions I analyzed. My second task was to develop correlation matrices using dense parcour, which was an R package that is used for partial correlation. Now, I implemented partial correlation for these figures because other correlation methods might increase the rate of false positives, and I want to minimize that. My third task in my research was to compare these correlation matrices between ASD and control patients and determine p-values for each correlation. Now, on the chart, you can see here on the bolded numbers reflect the telluric codes for each of the regions, and the numbers I've highlighted relate to connections between particular regions. Now, this number, for instance, 1.32 times 10 to the power of -5, is a connection between the right posterior cingulate cortex and the right medial prefrontal cortex. And values under 0.05 indicate that connectivity between these two regions is different between patients with and without ASD. Finally, my fourth and final task was to compare this connectivity to phenotypic data, namely each patient's ASD assessment scores. Now, these are verbal interviews of sorts conducted by researchers when they interview a patient. I specifically compared these connectivity values to specific data such as the full-scale intelligence quotient, verbal intelligence quotient, performance intelligence quotient, and 3 subscales on the revised autism diagnostic interview. Now, for instance, as you can see on the right, or as you see in the example data, subject number 51463 was a 20-year-old right-handed woman with autism. Now, her full-scale IQ, verbal IQ, and performance IQ values were 102, 101, and 103 respectively. And she scored a 24 out of 30 on the ADI social interaction subscore. The higher the number, the more likely it is that the person has some sort of hallmark of autism spectrum disorder, in this case, a deficit in social communication. Now, one past study only compared brain activity to phenotypic data, and this was just an exploratory measure. So I made sure to connect these connectivity values to phenotypic data to verify that the correlations that I had found previously were actually related to ASD. Finally, after using the Benjamin E. Hochberg procedure to decrease the false discovery rate, I found that the most notable neurocognitive phenotype of ASD was lower functional connectivity between the right posterior cingulate cortex and the right medial prefrontal cortex. Now, connecting this to phenotypic data, this manifests as a higher chance of restricted and repetitive behaviors, which includes stuff like repetitive hand movements or repetitive speech like echolalia. So why does this matter exactly? Overall, this method can be generalized for much larger data sets, which can allow researchers to develop a more nuanced idea of the neural substrate of ASD. This can enable researchers to identify a therapeutic target for future gene therapies or drug therapies, which can absolutely help the millions of children worldwide who are suffering from the more debilitating effects of ASD. These are my sources. I'd like to thank the Child Mind Institute for giving me the opportunity to present. I'd like to thank my mentor and my neuroscience teacher, Dr. Allendorfer, and my parents for supporting me through my research. Thank you again.
Thank you, Amith. I just want to point out that the ABIDE, the open source for neuroimaging of patients with autism disorder, was actually started here by Adriana DiMartino, our director of the Research Center in Autism. So nothing gives us more joy than to see that our open science efforts are working everywhere. Thank you for sharing your work, and congratulations on receiving this award. I want to say congratulations again to all of the students and their teachers and parents. I have to tell you, the quality of your work, the sophistication, the clinical implications are awesome. And if I saw them from students who were much older than you, I would still be impressed. But what really gives me hope is that you still had time to be on swim teams, on soccer teams, and even to have time to go watch some movies. So you are really amazing, and we look forward to following your achievements and scientific contributions over the years to come. We hope you'll all join us again at 5 p.m. when Dr. McCarthy and her proteges will present at the 12th annual On the Shoulders of Giants Scientific Symposium. This symposium started 12 years ago and was a small symposium that we held at Roosevelt House, part of Hunter College, and we had about 150 participants. As of this moment, we have 8,400 registrants who are going to join us at 5 p.m. At 6:30, we'll have a roundtable discussion moderated by Kathleen Marikengis, the intramural senior investigator of the Genetic Epidemiology Research Branch at the National Institute of Mental Health, and also the co-chair of the Scientific Research Council of the Child Mind Institute. They'll be exploring the impact of sex on the developing brain and the implications for mental health. It's going to be an exciting roundtable, and I hope you join us. Thank you all for attending this afternoon's ceremony, and please keep up your brilliant work.